principle of flight was a historic challenge, baffling men for many centuries. Yet today, after only 2/3 of a century of development, it has become a precise science. In history, man would study the birds and watch their movements for flight. But today, an engineer can determine the efficiency of an airplane design almost entirely by computer. Our study of flight will not, of course, be that involved, but we will study briefly some of the parts of the airplane and discuss generally how these parts perform in flight. The propeller, which is driven by the engine, provides the thrust and pulls the airplane through the air. As the speed of the airplane is increased during takeoff, the special shape of the wing causes the flow of air over the wing to move further and faster than the flow underneath. The difference in speed results in a partial vacuum on the top surface, and lift is created. This lift is increased as the speed of the airplane is increased and accounts for actual flight. At the rear edge of the wing and near the wing tip, the ailerons disturb the airflow, and by moving in opposite directions, simultaneously lift one wing and lower the other. The elevator at the rear of the stabilizer disturbs the air in a similar manner. This entire control surface moves in the same direction, either up or down. When the elevators are moved up, the tail of the airplane is pitched down, nose up. The airplane will climb. When the elevators are moved down, the tail is raised, the nose lowered, and the airplane descends. The rudder at the rear of the vertical stabilizer swings left or right, moving the tail to the right or left. It would be a lot easier to understand the parts we have just been talking about if we could see them on an actual airplane. And so I would like you to meet Jack Kramer and this colorful Beechcraft Musketeer. We've been talking, Jack, about the different parts of the airplane, and perhaps you would like to explain these parts to us.
Fine. Let's start with the wing.
All right.
As you can see, the top surface of the wing is curved more than the lower surface. And as the wing moves through the air, this causes the air passing over the top of the wing to travel further and faster, thereby creating lift. Now let's move around to the aileron. These are the ailerons. There's one located on each wing. They're used in turning the airplane. The ailerons are positioned by movement on the control wheel. If we move this aileron in this direction, the air passing under the wing would have a tendency to lift this wing. At the same time, the other aileron would be in this position, and the air passing over the top of the wing would have a tendency to move that wing down, thereby banking the airplane.
Is a bank the same as a turn?
No, but the airplane must be banked before it can be turned properly.
I thought the tail did that.
Well, it does in part, but let's take a look. In order to make what we call a coordinated turn, the rudder and aileron are applied at the same time. The rudder is moved by the rudder pedals on the cabin floor.
Aren't the rudder pedals also used in steering on the ground?
Yes, they are. You push on the rudder in the direction you want to turn. This is the other control surface located at the tail of the airplane. It's called the stabilator. Its movement is controlled by the wheel in the cabin. If you move the control wheel back, this moves the stabilator up, causing the nose of the airplane to pitch up. If the wheel is moved forward, the stabilator is moved down and causes the nose of the airplane to pitch down.
That is really interesting.
Now let's get in the airplane and look at the instruments.
Okay.
As you look at the instrument panel, you're probably wondering what the different gauges are for. And we'll start with the altimeter, which measures the weight of the atmosphere and indicates our height above sea level. The weight of the atmosphere changes from one part of the country to the other, and we have to make adjustments in the instrument when this happens.
How do I know what the setting should be?
We can get this information from the tower, and then we use this knob to set the small numbers in the window at the right side of the instrument.
Okay, now let me get this straight. We use the altimeter to determine our height above the ground or the altitude.
That's right, the altitude from the altimeter and our speed from the airspeed indicator. It shows us approximately how fast the airplane is moving through the air. This is determined by the velocity of the air entering the pitot tube.
Now where is this pitot tube?
It's located under the leading edge of the left wing.
Okay, the airspeed from the airspeed indicator.
That's right. And now to determine what direction we're flying, we can use either of the two compasses installed in the airplane. This is the magnetic compass, and it's used to determine the direction the airplane's flying. The last instrument we're going to discuss is the tachometer, which is located on the left of the panel. This instrument indicates how fast the engine is running. Now that we've looked the airplane over on the ground, we've seen all of the components and the instruments. We need to take it into the air and fly it to fully appreciate what the airplane will do. Have you ever flown a light airplane before?
No, I haven't.
Well, then why don't we do it today?
Okay.
If you're ready to go, I'll start the engine. This is the radio that we use for two-way communication with the tower, and the microphone we use by holding up close to our mouth and talking into it. When we call the tower, we want to tell them who we are, where we are, and what we want to do, and then we wait for them to give us the instructions. Okay, Diana, why don't you take the microphone and call the tower. Tell them who we are and that we're located in the east parking area and we'd like permission to taxi for takeoff. And you can use this number here for your identification.
Okay. Tower, this is Musketeer 6130N. We are in the east parking area and we would like to taxi for takeoff, is that? For takeoff.
Musketeer 6130 November, runway 18, wind 190 degrees at 12 knots, altimeter 3002, cleared to run up.
Okay, the tower told us that we are cleared to runway 18, which is in that direction. They also told us that the wind was from 190 degrees, which is a little west of south, and that the velocity was 12 knots, which is almost 15 miles per hour. And the altimeter setting was 3002, which we'll set into the little window on the right side of the altimeter now. Now that we're ready to taxi, if you'll put your feet on the rudder pedals and your hands on the control wheel, you'll be able to feel the control movements as we taxi.
Okay.
Now just relax. I think you'll enjoy this. To steer the airplane on the ground, if we want to go to the left, we'll push on the left rudder pedal. And if we want to go to the right, we'll push on the right rudder pedal. Now let's stop here for just a moment and check the engine out before takeoff. There is a list of things we check before each flight. It's known as a checklist. Tower, this is Musketeer 6130 November, ready for takeoff.
Musketeer 6130 November, cleared for takeoff.
Now move out on the runway and line up on the center line. And I'll advance the throttle until we have full power. Keep it right on the center line with the rudder pedals. And as we gain speed and the controls become more effective, we'll smoothly pull the control wheel back until we assume a nose-high attitude and the airplane begins to climb. Now that wasn't hard, was it? Let's climb up to an altitude where the air is probably smoother. And we'll start by turning the airplane. First, let's bank to the left by moving the control wheel to the left and pushing slightly on the left rudder pedal. Notice the horizon. To recover from this turn, push on the right rudder pedal and move the control wheel back to the right until the wings are level with the horizon. Now let's do that again. Always look in the direction you will be going before you turn. To turn the airplane to the right, we'll move the control wheel to the right and apply right rudder. To recover from that bank, we'll move the control wheel and rudder pedal back to the left until the wings are level again with the horizon. Now let's try some climbs and descents.
Okay.
To climb, we'll pull back on the wheel until the nose is up above the horizon, and to put it back down in level flight, we'll move forward with the control wheel. To descend, we push forward on the control wheel until the nose is below the horizon, and to bring it back to level flight, we'll pull back on the control wheel. The airport is off to the right, so let's turn in that direction. Now line the airplane up with the runway. Now we need to lose some altitude and slow the airplane up. So we'll start coming back with the throttle, reducing the power, keeping the airplane lined up with the center line of the runway. That's good. Now start coming back on the wheel. Just a little more. Very good. Keep coming back until we touch down on the main wheel. Good job. After a few more lessons like this, you should be ready for solo.
Well, thank you. I really enjoyed this lesson. I hope you two have learned a great deal about the airplane and flight and have enjoyed my experience of discovering flying.